guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And before any of you guys say anything in the comments, this is not an upside down 8, it's just how the font is. So it's not an upside down 8. So we have 3 to the power of a squared is equal to 81. Now, 81, well, this is what we want to do is we want to make these two bases the same. We have 3 and we have 81. And we want to change one of these bases so that they're the same as the other. Well, 3, it can't be simplified much more. So let's change 81, and 81, well, this is equal to 3 to the power of what? Well, 3 to the power of 3 is 27, so and 3 to the power of 4, well, that's 81. So x would be 4. So 81, I'm actually going to replace with 3 to the power of 4. So now we have 3 to the power of 4 is equal to 3 to the power of a squared. Now, because both of our bases here are the same, we know that our exponents here are the same as well, because if we have a to the power of x is equal to a to the power of y, this must mean that x is equal to y. So this means that a squared is equal to 4. So now we want to cancel out this power, so I'm actually going to take the square root, because remember, the square root is the opposite of the power. Now these two cancel out, and we are left with a is equal to plus or minus 2. Most people here would just say that the answer to this is 2, but it's actually positive or negative 2. So now this is our answer. Now I'm actually going to plug this in and check if it's right. So we have 3 to the power of 2 squared is equal to 81. 2 squared is 4, so we have 3 to the power of 4 is equal to 81. And 3 to the power of 4 is indeed 81. So we have 81 is equal to 81. And this is right. And the same thing for negative 2 squared. While taking the power of an even number on a negative number, we'll change it to positive, so this would be the same result. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x is equal to 5 to the power of 2x. Now, if we have something in the form a to the power of m times n, this is actually equal to a to the power of m to the power of n. And also vice versa. A to the power of m to the power of n is also equal to a to the power of m times n. So right here we have 5 to the power of 2x, and this, using this property, can be written as 5 to the power of 2 to the power of x. And now this is still equal to 3 to the power of x. Now let's simplify this a bit. 5 squared is 25. So now we have 25 to the power of x is equal to 3 to the power of x. Now if I divide both sides by 25 to the power of x, these two cancel out, and I'm left with 3 to the power of x over 25 to the power of x is equal to 25 to the power of x over 25 to the power of x is 1. Now, if we have something in the form a to the power of b over c to the power of b, this can actually be written as a over c to the power of b. So we have 3 to the power of x over 25 to the power of x, and this can be written as 3 over 25 to the power of x is equal to 1. However, I'm going to rewrite 1 as 3 over 25 to the power of 0. Now, because both of these bases are the same, that means the exponents are the same as well, meaning x is equal to 0. So this is our answer. And if we plug this value in to check, we get 3 to the power of 0 is equal to 5 to the power of 2 times 0. And 2 times 0 is simply just 0. So we have 5 to the power of 0. And any number to the power of 0 is 1. So 3 to the power of 0 is 1. And this is equal to 5 to the power of 0 is also 1. So this is right.